On August 25, 1764, an enthusiastic astronomer named Charles Messier was scanning the night sky, which looked like a black canvas, with his telescope in search of a comet in the skies of Paris. And suddenly he noticed a faint, hazy glow. It was so bright that at first he thought it might be a comet. But over the next few nights, when he studied it in more detail, he realized that it was stationary in one place. It didn't have a tail waving like a comet. After that, Messier recorded it in his famous catalogue, which was finally published in 1781, and that object was in the catalogue, M33 Triangulum Galaxy. At first, the world considered it a simple nebula. Everyone thought that it was just a large cloud of gas within the Milky Way, but in the sky it was nothing less than a mystery. For years it was just a number. M33 was one of the hundreds of such objects listed in Messier's catalogue, and then came the decade of the 1920s. Edwin Hubble planned to observe it again using the 100-inch Hooker telescope at Mount Wilson Observatory. He discovered Cepheid variable stars in it. Cepheid variable stars are those stars that brighten and dim at regular intervals, and this is the most accurate way to measure the distance to stars. Hubble found through his calculations that this was not a local nebula but actually a completely separate galaxy 2.74 million light years away from our sun. Since then, the Triangulum Galaxy has fascinated scientists. It is the third largest member in our local group after the Milky Way and Andromeda. But that doesn't mean it's an ordinary galaxy. Its spiral arms are broken and scattered as if some ancient painter left it unfinished. It doesn't have a central bulge, which we often see in other galaxies. No sign of a supermassive black hole. The ratio of gas to stars present in it is so unbalanced that it seems like this galaxy is still being born. This galaxy is not only alive, but it's also changing, moving toward Andromeda. Maybe in 3 to 5 billion years, these two galaxies will merge. Many questions about M33 remain. Is it really our neighboring galaxy, or is it a wandering world that got trapped in our local group? This is the story of the Triangulum Galaxy, that faint shadow which has been making us think for centuries. The Triangulum Galaxy. When you see it for the first time, it feels as if a child has drawn swirling lines in the sky with blue and white colors. It's not a perfect spiral like our Milky Way or Andromeda, but M33 is still classified as a spiral galaxy. It has two main spiral arms, but they're broken in the middle as if a huge storm came and pulled them apart. But between these broken spiral arms, there are numerous massive H2 regions where stars hundreds of times more massive than the Sun are born. Astronomers call them by names like New General Catalogue 604, New General Catalogue 595, and Index Catalogue 142. But actually, these are huge H2 regions, large clouds of ionized hydrogen, where the process of star formation begins. New General Catalogue 604 is so large that the Orion Nebula could fit inside it multiple times. This is a balloon of gas 1,500 light-years wide, filled with ionized gas at millions of degrees. And dozens of O-type stars are shining together. In the images from Hubble and James Webb, it looks like a giant red-pink bubble. It's as if another galaxy is being born inside a galaxy. But the most astonishing thing is the structure of this galaxy. Our Milky Way has a thick central bulge and a supermassive black hole, which is about 400,000 to 600,000 times as massive as the Sun. In Andromeda, there's a giant monster with a mass of about 100 million times that of the Sun. But nothing like that is seen at the center of the Triangulum Galaxy. Observations through 2024, they indicate that either there is no supermassive black hole there, or its mass is less than 3,000 solar masses. That means almost negligible. And this bothers scientists because the bigger the galaxy, the bigger its central black hole should be. This rule applies almost everywhere, except in the case of the Triangulum galaxy, where some scientists believe that either the black hole never formed, or it did but many years ago. It was thrown out in a massive collision, and both possibilities are frightening. Still, this galaxy is an expert at making stars. Its star formation rate is about 0.45 solar masses per year. A little less than our Milky Way, but many times more than Andromeda. This means it still has a lot of gas left. About 32 billion solar masses of hydrogen gas, which means there are still stars left to be formed while our Milky Way has already used up half its gas. This means the Triangulum galaxy is still young, and this youthfulness makes it somewhat dangerous, because it is moving toward Andromeda at a speed of 180 kilometers per second. In about 3 to 5 billion years, there will be a massive collision between the two, and when that happens, all the stars and gas present in the Triangulum galaxy will merge into Andromeda. But before that, the Triangulum galaxy is teaching us something. It is telling us that galaxies also have different natures. Some are calm, some are violent. In some, darkness rules at the center, while in others, there is only light at the center. When you look at the Triangulum galaxy from afar, it appears as a bright spiral located 2.74 million light years away. But by the time its light reaches us, it is already 2.74 million years old. That means we are not seeing it as it is today, but as it was when our ancestors on Earth were just learning to stand upright. Human evolution on Earth had just begun at that time, so what was happening in the Triangulum galaxy back then? New stars were being born in its spiral arms in massive nurseries like New General Catalog 604. Blue giant stars 200 to 300 times heavier than our sun were burning together. Their ultraviolet rays were heating the surrounding gas so much that it reached temperatures of millions of degrees Celsius. But the Triangulum galaxy has another feature that makes it completely different from our Milky Way. Here, there is very little dark matter present. The Triangulum galaxy has only 1/3 the amount of dark matter that our Milky Way has. This means that the grip of gravity on stars and gas here is weaker. That's why its spiral arms are so open and fragmented with no definite shape. In 2023 or 2024, the ALMA radio telescope mapped its center and the results were astonishing. The density of gas present at its center is very low, only 10 solar masses per cubic parsec. In comparison, if we look at the center of the Milky Way, this figure is thousands of times higher. This could mean that perhaps a galactic core hasn't formed yet in the Triangulum galaxy. It's still an incomplete galaxy, which is slowly evolving, and maybe that's why we don't see any supermassive black hole here, and it's also possible that one may never form. Additionally, there may be other possibilities such as a supermassive black hole at its center. It could be that it's very small and currently dormant. Some scientists believe that Triangulum is a rare example, a pure disk galaxy in which the bulge has not yet developed. James Webb Space Telescope discovered 59 new star clusters in its outer disk in 2024, which are only 10 million years old. That means they have just formed. This shows that the star formation in the Triangulum galaxy is still very rapid. Over the next few billion years, star formation will accelerate further. This will significantly increase the mass and density of its central region. And then perhaps its center will also become dense enough to create a black hole. For now, we are learning a lot from this galaxy about how in their early days our Milky Way galaxy and almost every galaxy formed in this universe actually evolve. But right now, this small neighboring galaxy of ours is calling out to us. Every night, a faint light shining in the Triangulum constellation. Scientists have already discovered much about this galaxy, but maybe that's the rule of this universe. The more we try to understand it, the more mysterious it becomes. The case of the Triangulum galaxy is similar. Even today, this galaxy remains a living puzzle for our astronomers. Its total mass is about 50 billion solar masses. Out of this, only 5 to 10% has formed luminous matter like stars, gas, and dust. The remaining more than 90% of it is dark matter. But even so, it is still only half as much as our Milky Way. This lack of dark matter makes its mysteries even deeper. It seems as if this galaxy has hidden itself behind a veil of dark matter. In 2024, the James Webb Space Telescope's NERCam and mid-infrared instruments together discovered 793 completely new stellar objects in its southern arm. These stars will become O-type or B-type blue giant stars, which indicates that the process of star formation in this galaxy is quite rapid. But if we look towards its center, we see a very big contradiction. The center of this galaxy itself remains its biggest mystery. In 2023, Atacama Large Millimeter Submillimeter Array and the Very Large Radio Telescope observed its core in millimeter and centimeter wavelengths, and the results were astonishing. No strong radio source was found there, no jet was found, and no compact object was found either. Finding the core of a large galaxy so mysteriously empty definitely raises questions. After all, did something terrible happen to this galaxy? A very terrible collision, because of which perhaps the shape of its spiral arms got distorted and all the mass from its center was stolen. Its supermassive black hole, even if it exists at its center, would not have a mass greater than 3,000 solar masses. Because of this, some scientists also call it a black hole-less spiral. But the mystery of not having a black hole in this galaxy can be explained in several ways. The first theory says that maybe the Triangulum galaxy has not yet felt the need for a supermassive black hole, because it already had so much gas that the stars formed from it were able to stabilize the galaxy's disk on their own. The second theory says that maybe a long time ago, around 8 to 10 billion years ago, the Triangulum galaxy had a massive collision with a large galaxy. Because of that collision, its main central black hole must have been thrown out. The theory of such recoiling black holes already exists in our science, and the Triangulum galaxy could be living proof of it. Along with this, it is continuously moving towards Andromeda at a speed of 180 kilometers per second. If we calculate from today, these two will collide after 3.5 to 4.5 billion years. In the beginning, both will overpower each other and destroy each other's spiral arms by pulling them apart. Then, for millions of years, the gravitational dance between these two galaxies will continue, and in the end, this galaxy will completely merge into the Andromeda galaxy. Sometime after their merger, our Milky Way will also join that collision, because we too are moving toward Andromeda at a speed of about 110 kilometers per second. The merging of these three galaxies will create a very massive elliptical galaxy, which astronomers have already named Milkomeda. But Triangulum's lifespan isn't that long. It will be swallowed up first. All its stars, all its gas, all its stories, and perhaps even those who tell the stories will be absorbed into Andromeda's belly. And we won't even be able to see its last glow from Earth, because by then our sun will have already become a red giant and all traces of humans will have vanished from Earth. Any humans who survive will have either migrated from Earth or settled in distant regions somewhere within the solar system. If you also want to see this unique galaxy, you'll have to go far away from any village or city light pollution. You'll have to go to a place where the sky is completely clear, and then you'll be able to see it in the sky. In the Triangulum constellation, you'll see a faint and hazy glowing spot. In this constellation, between Alpha Trianguli and Beta Trianguli, about 1.5 degrees southwest, you'll clearly see a faint oval-shaped cloud. It will appear at about 6.5 magnitude, which means it will be very difficult to see with the naked eye. But as soon as you use a 10x-50 binocular, the view will change for you. Let your eyes adjust to the darkness for 40-50 minutes, and then by zooming in 30-50x, you will have entered this unique galaxy. From 2026, the Vairasi-Reuven Observatory will scan the Triangulum galaxy again every 3 nights. In 10 years, we will be able to record the changes in brightness of more than 10 million stars in it. Every supernova, every microlensing event, every rotating gas cloud, we are going to capture every bit of its data. James Webb will take the complete 3D spectrum of its core by mid-2026, and then maybe we'll get the exact answer to where its black hole actually is. Maybe this will even change our understanding of science. But in the end, this galaxy too will fall prey to the jaws of time. And this game will keep going on like this in this infinite universe for infinite time. But until then, the Triangulum galaxy is still there and alive. Friends, what do you think is something really strange going on in this galaxy? Do let us know your opinion in the comments section. How did you like this video? If you like this video, be sure to like it and share it with your friends. For more such informative videos, make sure to subscribe to the channel and turn on the bell notification. Friends, we'll meet again soon with another new and fun video like this. Until then, stay curious, be happy, and goodbye.